So everyone go ahead and open your books to that section. Yes?
Can I get a book?
Oh, yes. Here. I have to number it still. I think it's 90.
Thank you.
So everyone go ahead and open your books to that section. Now, perpendicular bisector. Oh, I remember now. Okay, if two lines are perpendicular, what angle do they meet at? What angle? 90 degrees. Very good. If I were to draw two perpendicular lines, you all right, man? If I were to draw two perpendicular lines, then they would create four sets of 90-degree angles. Hold on, I'll just open some stuff up. What is this? Okay, so let's take a look. I draw one line here. Okay. And we'll call this line A, B. And now I want to draw a perpendicular bisector. So the first thing I want to talk about is perpendicular. Perpendicular means it meets at 90 degrees, right? We understand what perpendicular lines are, that's good. But what about a bisector? What does a bisector do? Yes, if I think unicycle, how many wheels? One. If I have a bicycle, it's two, so bi is two. If it's sect, like dissect, right, I'm cutting something, so bisect means I cut it down the middle, or I cut it into two congruent segments. So a bisector cuts something into two congruent segments. So a perpendicular bisector is a line that will cut a line segment into two congruent segments, and it will do it at a 90-degree angle. Does that make sense? So here's line M, let's call it. Let's call this line M. And line M is the perpendicular bisector of segment AB. Does that make sense to you guys? Perpendicular bisector. So if it intersects at this point, we'll call it C. Then what do I know about line segments AC and BC? They're congruent. So I can show that like this. Right? Now, we're going to talk about the perpendicular bisector theorem. So everybody in your books on page 710, go ahead and read what it says about the perpendicular bisector theorem. And in fact, you have a picture right there. That is basically what I'm constructing for you guys. So I'm just going to put this in the corner so you can refer to it. Okay, so let's break this down. All right, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, so let's break that down. A point on the perpendicular bisector of the segment. The perpendicular bisector is here, line M. So raise your hand if you think that point is on the perpendicular bisector. Raise your hand if you think that point's on the perpendicular bisector. Raise your hand if you think this point is on the perpendicular bisector.
Yes.
Nice. Okay. So we'll call that point P. Okay, and you notice that this diagram is, I'm just basically reconstructing the diagram. Another thing to point out, if this is a perpendicular bisector, it does meet it at 90 degrees. So we have that 90-degree angle there. Then it is equidistant from the endpoints of the segment. So the segment being bisected is segment AB. So what are the endpoints of segment AB? Who can tell me? Someone tell me one of them. Rachel, give me one of the endpoints of line segment AB. Endpoints. Yeah. Yeah. Sometimes questions are so easy that they seem hard. Jenna, what's the next one? B. Good. So those are the two endpoints right there, you see? Now, Brianna, what does equidistant mean? Equidistant. Yeah, nice. So the point P, this point P is equally distant from A as it is from B. So I'll draw that with these yellow lines here. So that yellow line, that distance, is equal to this distance here. Does that make sense to you guys? So they're equally distant. So if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Simple as that. Okay? So what does that mean? If this is 8, what's this? 8. Simple as that. So there's two line segments are congruent. Any questions about that? Okay. All right, now, you don't actually have these. This is from a worksheet that you don't have. But go ahead and do number 1. Go ahead and do number 1. You don't have it. I'm going to put it up on the screen. You're just doing number 1 right now. So take a look. You don't actually have this in your book, so you can just do it on scrap paper or whatever you need to do. Given AC is the perpendicular bisector of GH, solve for GH and CH. Seconds. Okay. So I highlighted the perpendicular bisector in red, AC. And then it's telling me it's the bisector of GH. So what do I know about GB and BH? They're congruent, right? And their endpoints are G and H. And we see that we've got a point here, C, on the perpendicular bisector, which means that that point C is equidistant from the endpoints. So it's equidistant from point G and point H. So this leads us to the answer for CH. If GC is 12, then what's CH, class? 12. Simple as that. Now GH is a little bit more challenging. You might be inclined to say, oh, this is 8, so GH is 8. But that's not GH, that's BH. So if this is 8 and this is 8, what's GH? 16. It's the sum of both segments. Is that pretty clear? Okay. So the next one is number 2. So go ahead. I'm going to put this up. And you'll do number 2 in a very similar fashion. So go ahead and take the time. Make sure you're writing or figuring it out, please. By the way, we're going to have another project in this unit because it's all geometry, and geometry is fun to do projects with. So I'm not sure what it will be just yet, but put it on your radar. Okay, let's take a look. CD is the perpendicular bisector of PR. CD is the perpendicular bisector. So here's this. Okay, PR, there's the endpoints. So it's asking me for CR. Well, if PC is 17, then CR is 17. And here, this one is actually easier. QR is 15, then PQ is also 15. You see? It's pretty simple. Okay? All right. Any questions on that? No. Okay. Didn't think so. Now, before I move on to the next thing, Pythagorean Theorem. What is Pythagorean Theorem? Nice. Pythagorean Theorem is if I've got a right triangle. That's not a right triangle. That's not a right triangle either. I'll try my best. This is a right triangle, we'll say. This is A, this is B, and this is C. C is the hypotenuse. How do you know which one is the hypotenuse? Yeah, it's like if the right angle was an arrow, it would point to the hypotenuse. So we know A squared plus B squared equals C squared. Okay, that's the Pythagorean theorem. You guys should be familiar with that. Go ahead and turn to page 714 in your books right now. So this is your homework, part of your homework. I want you guys to consider number 8, because if you can do number 8, you can do the rest of them. So I want you to go ahead and consider that now. And you're also given up here that BP is the perpendicular bisector of AC and CQ is the perpendicular bisector of BD. So you're going to have to use that. As well. So I'll give you some time. Go ahead and do number 8, please. Mm-hmm. In your homework, page 715. You're going to have to use Pythagorean theorem. It's So I just showed it to you. Okay. So I've highlighted the perpendicular bisectors in red. We're given that PB is 3 and AD is 12. It asks for the length of PC. So PC is this length right here. So we're asked to solve for this length. Well, if I break that triangle out, we see that we've got this side here, which is 3. We've got this side here, which we don't know. And then we've got that side there, which I've shown in blue. First things first, what kind of triangle is this? A right triangle. And how do I know that it's a right triangle? Because they are the what kind of bisectors? Perpendicular bisectors. So it intersects at a 90-degree angle. So this is 3. What about this blue side? Is it 12? 4. How is it 4? How do we know?
12 divided by 3.
Yeah. 12 divided by 3, right? Is 4. Cool. All right, so how do we find x? What is it, class? The what theorem? Pythagorean Theorem. Good. We get 3 squared plus 4 squared equals x squared. 3 squared is 9 plus 4 squared is 16 equals x squared. 9 plus 16 is 25 equals x squared. What do we do now? Square root both sides. Very good. Now, usually we would say plus or minus when we're taking the square root, right? But why are we not interested in the negative here? Yeah. It's impossible for the length of a triangle side to be negative. So it's just 5. Okay? So I think that's pretty straightforward, but if you don't realize you have to use Pythagorean theorem there, it would be challenging. Okay. Any questions on that? All right. I'll bring that back up in just a second. Phone call. Someone have a question? Yeah. Oh, no, he's good. He's good. Just mark him present. Okay. Next, let's take a look at this, guys. Oh, no? All right. Let's take a look at this. All right, when two lines meet each other, they're perpendicular. They meet each other at 90-degree angles. So let's take a look at this. Number 1, it says, what's the value of z? This isn't in your book. So what's the value of z? Well, this is 90 degrees, so what's the value of z? First off, z and this angle, what type of angle pair?
Vertical.
Vertical.
So they're congruent. So if this is 90, then z is 90 degrees. Okay? And then it says here, if y is 50 degrees, well, first off, before I go there, I know that all of these angles, this angle here and this angle, they're all 90 degrees. So it then tells me y is 50. Well, if y is 50, what's x? It would be 90 minus 50, which is 40 degrees. Okay? And then the weird thing is then it like basically disregards number 2 and it goes on to number 3, pretending that number 2 doesn't exist. And it says v is equal to 60 degrees. Then what would w be? W would be 90 minus 60, which would be 30 degrees. Why does this picture not make sense right now? If I write that this is 50 degrees and that's 60 degrees, why does that not make sense? They're vertical angles. They should be congruent, right? So that's why I say like number 3 disregards number 2, which is kind of confusing when you get problems that are like that.
So that's not correct. That picture isn't correct. The
Yeah,
mathematical
there, like each question is fine.
It's
If
not
I
proportional.
disregard number 2, then number 3 is fine. If I disregard number 3, number 2 is fine. Do you understand what I'm saying? Okay. But the picture wouldn't be correct. All right. So why did I do that? I did that to help you with parts of your homework assignment, which are like 9, 10, and 11. So those are different angles that you'll be asked to solve for. But now I want to talk about number 15. So this is on your homework as well. And this is the last thing that we're going to really talk
And the
about.
homework-
The homework goes up to number 17, but it starts at number 5.
I have a question.
Yep.
Are we to assume that this is a perpendicular cosine? All of this.
So PA is equal to PC, BA is equal to BC. So you know that it must be perpendicular bisector.
Okay.
Does that make sense?
Yes.
Okay. So number 15 in your homework. All right, the first thing it says, 2 lines intersect to form a linear pair with equal measures. So go ahead and draw that. Draw a picture of 2 lines that intersect to form a linear pair with equal measures. Go ahead and draw that. And there's only one real way that that can be drawn. Okay. So the first line I'll draw like this. And now let's take a look. Let's say I draw my second line like this. Did I form a linear pair? Yeah, I formed a linear pair, but do they have equal measures, both angles? No, so that's not going to work. What about here? Did I form a linear pair? Yeah, but they're not equal angles, right? So what's the only way I can form a linear pair with equal angles? If the two lines are perpendicular. So that's that right there. Okay? And then it says to us, one angle has the measure 2x degrees. So this angle is 2x degrees. And the other has the measure 20y minus 10 degrees. Solve for x and y. So you should be able to do that now. What are the measures of both of those angles? 90. They're both 90 degrees. We know that. They have to be. So you should be able to solve for x and y now. Okay. Solve for x. 2x equals 90. Divide both sides by 2. Get x equals 45. To solve for y, I get 20y minus 10 equals 90. Add 10 to both sides. I get 20y equals 100. Divide both sides by 20. And I get y equals 5. Cool? Alright, number 16 is very similar to that. You also have to do number 17, so that's like actually a verbal question and answer type of thing. So you're going to just write out what you think. And so you start at question number 5. So page 714, number 5 through 17. That is your homework. Any questions? All right.